Good morning, class. Today in this class we will learn electric dipole. In the previous class we have learned electric field lines and we have also solved some problems on Coulomb's law of force. Now today we are going to learn electric dipole. Just consider two charges, opposite charge, and separate these two charges with a small distance. Say for example, we have considered two charges, that is one charge as plus, another charge as minus, and we have kept these two charges apart at a small distance. This is minus charge, this is plus charge, and there is a small distance between them, and this is small distance, this is the small distance. Now this entirety, or we can say this system in which two opposite charges, see these are opposite charges, this in this entirety, when two opposite charges are separated by small distance, the distance between these two charges is very small, a small distance, then this entirety or this system is called electric dipole. Means two pole. Okay, di means two, pole means polarity. Dipole. Okay, one pole, another pole. So this is called dipole. So we will learn about dipole in this class. Okay, so the definition is a system. So we have considered a system. A system consists of two equal. These two charges are equal and opposite. They are opposite in nature. This is minus charge, this is plus charge. So they are opposite in nature, separated, they are apart by a small distance. By small distance. See, there is a distance and this is a small distance. So this system is called electric dipole. Now we will draw a proper diagram of electric dipole. Okay. Class, same. This is the proper diagram of an electric dipole. We have considered 2 point charges, minus q, plus q. They are opposite in nature as per the definition, and they are separated by small distance. And we have considered the distance as twice a. Why twice a? For easy calculation. Because we will use this distance in calculation, so it will be better to use twice a in place of a. Okay, if we use a, then for this half distance we have to write a by 2, which is difficult in calculation. So we generally use twice a as the distance between the two charges. Okay, and the length that is twice a is the length of the dipole. So we can write length twice a is equal to length of the dipole. Length of the dipole. Okay, AB is a dipole and twice A is the length of the dipole. Now we have to study some parameters or some terms in electric dipole, that is dipole moment. Okay, dipole moment. This dipole moment is represented by a small p vector. We will learn. Okay. So this dipole moment, it is actually the strength of the dipole. It gives the strength of the dipole. It measures the strength of the dipole. Dipole moment. Dipole moment measures the strength of the dipole. Okay. Now, what is electric dipole? What is dipole moment? Okay. So dipole moment is defined as it is a vector quantity. Okay. So first note, it is a vector quantity. Dipole moment, it is a vector quantity. quantity. So we are representing this dipole moment as p vector, a small p vector, and this vector starts from negative charge to positive charge. Its direction is from negative to positive. Its direction is from minus q to plus q. Okay, and if it is vector, then let us define the magnitude of this vector. So the magnitude of this dipole moment is defined as the product of either of charge and the distance between them. Its magnitude is the product of either charge and the distance between them. Okay. Now, its magnitude is the product of either charge and distance between them. So we can write P vector is equal to Q into distance between them. So we can write twice P. Okay, and it's along minus q to plus q. Okay, this is the dipole moment of an electric dipole, which gives the spin of the dipole, and its unit is charge and distance, means coulomb meter. This coulomb meter is the unit of dipole moment, and this dipole moment is a vector quantity. Okay, this is a vector quantity, and it is always along a to b, or we can say minus 2 plus charge. Okay, and there is a term O. This O is actually the center of the dipole. This is the center of the dipole. Okay, this is the center of the dipole, and its the dipole moment, its unit is cm, that is coulomb meter. Okay, the SI unit cm, and this small p indicates dipole moment, and we will use this dipole moment in place of twice aq in many formulas. Okay, we will just replace twice aq with p. That is we can write P is equal to twice a q. This is the dipole moment. Okay, that's all for today's class. Okay, in the next lecture we will learn. In the next class we will learn electric field intensity on axial line of a dipole. That is, this is the axial line. This is called axial line. We will calculate the electric field intensity on this axial line, and next electric field intensity on equatorial line. Divide or draw a perpendicular passing to the center of the dipole. This is called equatorial line, which divides the dipole into two parts. Equatorial line. Okay, this is equatorial line, and this one is axial line. So we will find electric field intensity on axial line and equatorial line in the next class. Okay, till then, thank you, goodbye, take care.